The notes for Unit 5, Lesson 2 will cover molar mass and the mole. So in this lesson, we will convert from moles to grams using molar mass conversions. Yesterday, we converted between atoms and moles, and today we'll convert between moles and grams. So make sure you have your notes packet available, make sure you have your yellow periodic table packet, and then you will also want a calculator close by. All right, so yesterday we talked about how big is a mole. So a mole is 6.02 times 10 to the 23rd particles. So if you're talking about copper, or sulfur, those are regular elements. So copper, 1 mole of copper would have 6.02 times 10 to the 23rd atoms. If you're talking about a compound, like sucrose or copper sulfate, sodium chloride, mercury 2 oxide, since those are compounds, those would either be molecules or formula units. So 1 mole of mercury 2 oxide would contain 6.02 times 10 to the 23rd formula units. So all of those terms, like molecules, atoms, particles, formula units, those all represent particles. So it's not easy to count out all these particles, right? That would be a complete waste of time. And so in order for us to measure out 1 mole of these substances, we can use molar mass. So this is the way that we would measure out these substances in the lab. So molar mass is the mass of 1 mole of substance. And how you find the molar mass is you look on the periodic table. So the mass given on the periodic table is the molar mass of each element. So the molar mass of an element is the atomic mass from the periodic table, and the unit is grams per mole. So if we were in the lab and you wanted to measure out 1 mole of copper, you would put it on the scale and you would measure or pour out as much copper as you would need to get to 63.546 grams of copper. And that sample would contain 1 mole of copper. If you were measuring out a compound like salt, salt is NaCl, then you would add up the molar masses from each element. And the unit would be the same, it would still be grams per mole. So for Na and Cl, you would take the molar mass of Na plus the molar mass of Cl. You would want to keep as many decimal places as possible, and that would be your total molar mass of salt. So if you wanted to measure out 1 mole of salt, you would put the beaker on the scale and you would dump salt in until you reached a mass of 58.44 grams, and that would equal 1 mole of salt. If you wanted to find the molar mass of NaNO3, this formula has 1 sodium atom, 1 nitrogen atom, and 3 oxygen atoms. So you would take the molar mass of sodium plus the molar mass of nitrogen, and oxygen, you have to multiply that molar mass by 3. So you'd have 22.99 plus 14.01 plus 16 times 3. And that would give you your molar mass of NaNO3. All right, so in your notes, we'll add 2 examples. If you were finding the molar mass of SO3, you would again use your periodic table. So the mass of sulfur is 32.07, and it's grams per mole. Oxygen has a mass of 16.00 grams per mole. If you look at the formula, we have 3 oxygen atoms, so we have to take this value, times 3. So in your calculator, 32.07 plus 16 times 3 would give you a molar mass of 80.07 grams per mole. So 1 mole of SO3 would have a mass of 80.07 grams per mole. When you are adding and subtracting with sig figs, remember it goes by least number of decimal places. So we want to keep all the decimal places that the number gives you from your periodic table to have the most accurate molar mass. So you'd keep those 2 decimal places. All right, one more example is if you found the molar mass of AlNO3 So go ahead and pause the video and try this one on your own, and then come back and check your work. All right, so in this formula, we have 1 atom of aluminum. The 3 is on the outside of the parentheses, so the 3 applies to the nitrogen and the oxygen. So for aluminum, we just have 1 atom of aluminum, and that molar mass from the periodic table is 26.98 grams per mole. Nitrogen, we have 3 of them. So we're going to take 3 times the mass of nitrogen. Whoops, I was writing down the wrong mass. Sorry. 3 times the mass of nitrogen in grams per mole. And then oxygens, we actually have 9 oxygens because you would multiply the number outside the parentheses to the number inside the parentheses. So we have 9 oxygen atoms, and each oxygen atom has a mass of 16.00 grams per mole. So if we take all of those and add them together, we would end up with, whoops, a molar mass of 213.01 grams per mole. All right, so when you're doing mole conversions, you're going to use these molar masses in your mole conversions. So the conversion factor that you're going to use is that the molar mass in grams, so this again is the mass from the periodic table, is equal to 1 mole. So we'll do 2 sample problems on this next slide. All right, so in your yellow packet, towards the back, you have your mole map. Remember, we are only on side A of the mole map, which is the left portion. Today, we are only using this conversion. So we're only going from mass to moles or moles to mass. Yesterday, we used this conversion between moles and particles. So when you have all of these problems mixed in together, you can use your mole map to find your starting and ending point, and then that mole map will have your conversion to convert in between. All right, so the first one, convert 9.45 moles of Al2O3 to grams. So we want to end with grams, so we're going to put question mark grams. So here's our question mark. And we know that we have 9.45 moles. So moles is our starting point. So if I find my starting point and my ending point, then I'm going to use this to figure out what the conversion factor is to get from one to the other. So once you have your initial value, I'm going to set up my chart. Whatever unit you start with from the problem gets transferred to the bottom of the second step because we need that unit to cancel out. If we know that we're using this process from moles to grams, we know that this is my conversion factor. If moles is on the bottom, the number 1 goes with the unit mole. Whatever it's equal to goes on top. So molar mass is going to go up top. Molar mass we find from looking at the periodic table, so we have to add up the molar mass of Al2O3. So aluminum is 26.98 times 2 plus 3 times oxygen. That gives us a molar mass of 101.96. So once I have my conversion set up, moles is going to cancel out with moles. I'm left with grams, which is what I want. So I know that I'm done. I'm going to multiply the numbers across the top. and divide by the numbers along the bottom. So when I take 9.45 times 101.96, then I have to round my answer to sig figs. So 3.45 has 3 sig figs. 101.96 has 5 sig figs, so 3 is going to be my least number. So my final answer would be, 964 grams. Because the 5 following the number in your calculator is 963.5, and that 5 is going to cause the 3 to round up. All right, so for the second example, we want to determine the number of moles. So we have question mark moles is equal to, and we know that we have 92.2 grams of Fe2O3. So I'm going to start with whatever number the problem gives us. Whatever unit I start with gets transferred to the bottom of the next step. I'm going to erase this so we can make new markings. So we are going from grams to moles. So this is the conversion factor that I'm going to use. Molar mass is grams, so that's going to go on the bottom. So I have to find the molar mass of Fe2O3. So we look on the periodic table, 2 times the mass of iron plus 3 times the mass of oxygen gives me a total of 159.70. And that's how many grams are equal to 1 mole. So whatever that's equal to goes on top of the chart. Whoops. The unit grams cancels out. I'm left with moles, which is what I want. So now I multiply the numbers across the top. So 92.2 times 1 divided by 159.70. And again, I have to round to sig figs. So the least number of sig figs in the problem is 3. By the way, you don't count the 1 mole. That doesn't count for sig figs. You only use the measurements. So you use the grams and the molar mass. So with 3 sig figs, my answer would be 0.577 moles. So same process that you used from yesterday, except for now you're using a different conversion factor in the second step. So when you are converting from moles to atoms or particles, you use 6.02 times 10 to the 23rd. When you're converting between moles to grams, you use the molar mass.